Hey, Sunshine. So let's talk about complementary angles. So complementary angles are two angles that add up to 90 degrees. So when you use the definition of complementary angles in a proof, usually you're swapping between a statement that says angle 1 and angle 2 are complementary. So you can have a statement angle 1 and angle 2 are complementary, and then your next statement would be the measure of angle 1 plus the measure of angle 2 equals 90 degrees, or the other way around. You start with this statement and then your next statement is going to be this, and either direction your reason is going to be definition of complementary angles. So complementary angles can form a right angle if they're adjacent. So this 60-degree angle and this 30-degree angle are physically forming a 90-degree angle because the angle addition postulate tells us that the larger angle equals the sum of the smaller pieces. But this 60-degree angle and this 30-degree angle are also complementary, even though they're nowhere near each other. They do not form a right angle because they are not adjacent. There isn't a right angle here. They don't have the same vertex. They're not forming anything. When we solve problems using complementary angles, this is angle 1 and this is angle 2. So if we know that angle 1 and angle 2 are complementary, then I know that the measures add up to 180 degrees to 90 degrees. So I just substitute my two given algebraic expressions into that equation. So I have angle 1 plus angle 2 equals 90 degrees. And then I'm just going to solve my equation. So I solved for x and I did an informal proof. I call it informal because I didn't write this out formally. Normally, when you do a subtraction property of equality or division property of equality step, you would write the whole equation, including that minus 10 on each side. I just wrote the minus 10, so this is not formal notation here, but it's a little easier for you to follow what I'm doing, I think. And so I wanted to show you the work for the solution, but I included all of the properties that I'm using as a review of your proofs. So we were given these values in the picture. We were given this statement in the text. That's why it's typed. So this is given information, and then I just wrote it around my given information, again with the informality. And then the definition of complementary is that if I know that they're complementary, then I know that they add up to 90 degrees. And I substituted the values that I had into that equation. I combined like terms. 5x plus 3x is 8x. Subtraction property of equalities when you subtract something from both sides of your equation. Simplify. Division property of equality is when you divide both sides by the same number. So those properties of equality are when you add, subtract, multiply, or divide the same thing on both sides. And then finally, I get x equals 10. And so now I know the value of x. So if I want to solve for the measure of angle 1, I'm just going to substitute that x value in to the expression that I was already given up here. And then we simplify and we get x equals 3, or angle 1 equals 60. And we do the same thing to get the measure of angle 2.